The command pattern. Reusable logic that actually works in production. Hello and welcome to episode number 20 of the Unity Performance Task Force podcast. I'm your host, Ruben from TheGameDev.Guru, and as usual, I'll kick things off with a question for you. Have you ever built a tutorial system that blocks the entire UI flow until the player taps through 5 screens? Or try to implement undo-redo in your level editor and realize you need to track not just what changed, but how to reverse it? Or worse, attempted to add replay functionality to your multiplayer game and discovered you're now maintaining a parallel state machine just to record player actions. Sounds familiar? If so, this episode is for you. Today we're talking about the command pattern. Now, before you roll your eyes and think, oh great, another academic design pattern lecture, hear me out. This is one of my favorite patterns. I've used it over and over in production. And I'm not talking about toy projects. I'm talking about games with over 40 million players. Games that shipped on Android, iOS, and web. Games where the pattern didn't just make the code cleaner, it made entire features possible. So what is the command pattern and why should you care? Here's the short version. The command pattern lets you group logic and data together to achieve one atomic goal. Think of it like a method, except instead of just calling it and forgetting about it, you create an object. That object holds the method logic, but it also holds the data the method needs. And because it's an object, it sticks around. You can pass it between systems, you can store it in a list, you can execute it now or later, you can even replay it. That's the magic. Commands are reusable logic that can be synchronous or asynchronous, and they carry their own context. Now let me make this practical. Let's talk about where I've actually used this. I worked on a game called Diamond Dash. It's a casual match 3 style game. UI heavy. Lots of pop-ups, lots of menus, lots of flows. Tutorial screens, purchase screens, leaderboard screens, spinning wheels, you name it. And behind every one of those flows, I used commands. Here's an example. When you tap the plus icon to buy more lives, the game needs to do a bunch of things. It needs to load the purchase pop-up. It needs to fetch fresh pricing data from the backend. It needs to block input on the background UI so you don't accidentally tap something else. It needs to wait for you to complete or cancel the purchase. And then it needs to clean up and return control back to the main menu. That's not a one-liner. That's a workflow. And workflows need coordination. So instead of scattering that logic across 5 different scripts, I created a command. Show lives purchase pop-up command. One class. That command handles everything. Load the scene additively, fetch backend data, block background input, wait for the user action, and load the scene. Done. From the caller's perspective, it's that simple. You create the command, you run it, and you wait for it to finish. When it finishes, the result is stored in the command object. You just read it. Another example. Let's say the player just finished a match and leveled up. You want to update their profile data, send an event to the backend, trigger some confetti on screen, update the UI progress bar, and maybe show a celebratory pop-up. Again, that's a workflow. So you create an increase level command. That command does all of it. Data update, backend call, visual effects, UI refresh, one command. And because it's asynchronous, you can wait for the backend response before proceeding. No callbacks, no coroutine spaghetti, just clean, linear logic. Here's another one, tutorial systems. Tutorials are a nightmare to implement cleanly because they interrupt the normal flow of your game. You land in the main menu, but before the player can do anything, you need to check if they've completed the tutorial. If not, you need to block the menu, show step 1, wait for a tap, show step 2, wait for another tap, and so on. With commands, you create a show tutorial command. That command owns the entire flow. It puts up a blocking overlay, It shows each step, it waits for user input, and when it's done, it returns control to the main menu. The main menu doesn't need to know how the tutorial works, it just invokes the command and waits. So that's the why. Let's talk about the how. There are many ways to implement the command pattern. I'm going to show you the way I like to do it in Unity. It's simple, it's flexible, and it scales. First, you create a base class called async command. This is an abstract class with one method, run-async. That method returns an inher which means you can yield inside it. That's how you get async behavior. You just use coroutines. Then, for every specific command you need, you create a subclass. Let's say ask for input command. That command derives from async command and implements run-async. Inside run-async, you do whatever the command needs to do. In this case, load a pop-up scene additively. Wait for the user to type something and press a button. Store the result in a field on the command object. And load the scene. Done. Now here's the clever part. Because the command is an object, you can store data on it. You can pass parameters in the constructor. For example, maybe you want to set the title of the pop-up. So you add a constructor that takes a title string, store it in a field, and then when you load the scene, you pass that title to the pop-up root script to configure the UI. And because the command is an object, you can also store results. When the user presses the button, you store their input in a result field. The caller just waits for the command to finish, then reads that result field. From the caller's perspective, it looks like this. You create the command. You pass it a title. You start a coroutine that yields on the command's run-async method. When the coroutine finishes, you read the result. Clean, simple, reusable. Let's talk about some variations and gotchas. First, commands can invoke other commands. You can nest them. For example, your show tutorial command might internally use a show overlay command and a wait for button press command. That's fine. Commands are composable. Second, commands can be synchronous or asynchronous. I like to have two base classes. One for async commands, which return inher, one for sync commands, which return void. That way you don't have to define empty async methods for commands that don't need async behavior. Third, if you want undo-redo functionality, you store your commands in a stack. When you execute a command, push it onto the stack. When you undo, pop the last command and call an undo method on it. That method uses the data stored in the command to reverse the action. Same for redo. Just pop from the undo stack and push onto the redo stack. Fourth, if you want replay functionality, store your commands in a list. When you want to replay, iterate through the list and execute each command. Because each command holds all the data it needs, the replay will produce the same results. Fifth, if you're worried about memory allocations, you can pool commands. Instead of calling new every time, you grab a command from a pool, configure it, execute it, and return it to the pool. That eliminates the per frame allocation cost. Now let's talk about when not to use commands. Commands have overhead. You're allocating objects. You're using coroutines which have CPU cost and memory fragmentation. So I wouldn't use commands for high-frequency gameplay actions. Don't create a command for every bullet fired in an FPS. Don't create a command for every frame of movement in a racing game. But for one-off actions, UI workflows, menu transitions, pop-ups, tutorials, anything that happens a few times per second or less, commands are fantastic. Here's the litmus test. If you're building something in the gameplay loop that runs every frame or multiple times per frame, don't use commands. If you're building something in the meta layer, menus, pop-ups, settings, purchases, tutorials, use commands. Let me give you the action plan. First, identify a workflow in your game that involves multiple steps, possibly async, possibly with data that needs to persist across those steps. Good candidates are pop-ups, tutorials, multiplayer command synchronization, or undo-redo systems. Second, create your base async command class, one abstract method, run -insync, returning in her insunter. Third, create your first concrete command. Pick something simple. Maybe show pop-up command. Implement run async. Load the scene, wait for user input, and load the scene. Fourth, add data to the command. Pass parameters in the constructor. Store results in fields. Make the command self-contained. Fifth, use the command in your calling code. Create it, start a coroutine that yields on run async, read the result when it finishes. Sixth, test it. Make sure the flow works. Make sure data persists correctly. Make sure async behavior works as expected. Seventh, expand. Once you have one command working, you'll start seeing patterns everywhere. Refactor other workflows into commands. Build a library of reusable commands. Eighth, if you need undo-redo, add an undo method to your base class and maintain a command stack. If you need replay, maintain a command list and iterate through it. Ninth, if performance becomes an issue, add pooling. But honestly, for most games, you won't need it. Commands are usually used in low-frequency contexts where allocation cost doesn't matter. Let's recap the three big ideas. 1. The command pattern groups logic and data together in a reusable, self-contained object. That makes it perfect for workflows that are async, need to persist data, or need to be recorded and replayed. 2. In Unity, the simplest implementation is an abstract async command class with a run async method returning in her insunter. Concrete commands derive from that, implement their logic, and store data and results as fields. 3. Commands shine in UI-heavy flows, tutorials, multiplayer synchronization, and undo-redo systems. They're overkill for high-frequency gameplay actions. Use them where workflows matter more than per-frame performance. If you want a second pair of eyes on your architecture, we do focused code reviews and training sprints. We can help you identify where patterns like this will save you time and where simpler approaches are better. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time.